So, okay, we go before we go to the design. Okay. All right. Okay. So, what's the question? You are required to. Okay, let's read what your friend has written. Yeah. Yes, Alia.
Sorry, bila betul tekan.
Oh, you go. Okay. Anything else? Adita? I heard voice just now. Okay, let me continue. Yeah, so the question is just asking you to calculate the static error constant, yeah, with the given dominant pole at that point. Okay, minus 0.694 plus J 3.426. Yeah, 3.926. Okay, that's the point given in the question. Please refer to 1D, tutorial 1D. Yeah, D Denmark. Okay. All right. Now, from the equation, you have that, yeah, so to use for your KGH. Okay. And then using the magnitude criterion, yeah, you use to that equation to calculate your K. Why you need the K? Because you need it to calculate the KP. Okay, very clear that your friend have shown here. Yeah, and the okay, it's just that that should be in magnitude in a constant. Yeah, Nabila. Yeah, not with J. Okay. Okay, let me check the value. 164. Yeah, it should be 164. Can you double check again one more time, Nabila? Yeah, your answer there should be 164, taking the magnitude. Yeah, all right, because K is a constant, right? All right. Now using the value there, okay, that should not be it. Yeah, with no J there. Yeah, only a constant. And then you put the K back into the KGH and start calculating the answer there. Okay, still with J, no J there. Yeah, arithmetic constant. Okay. So it should be 8.2 something there. Okay, recalculate. Okay, and then you get your error. Okay. Um, all right, that is extra, right? Yeah, so okay, it's okay, no problem, because that's equation also correct. 1 over 1 plus KP. Very good. Any question? It's a simple question, but it shows you how important, yeah, the K for you. K, if you know K, from a given point, you can calculate your K. From K, you can vice versa, calculate the point. From K, if you have the point, okay, if you can calculate the point, from the point, it gives you several other things about your performance of the system. Okay, so you have to think about it, yeah, in a wider view. Okay, and also from K, you can calculate your error, right? Not to be ignored, okay, because K is part of the plot diagram, okay, part of the system already. Yep. All right, any question?
Madam,
Yeah,
kalau saya nak tanya soalan 1A tadi tu boleh tak?
boleh. Yang mana satu?
Yang untuk cari angle of departure tu.
Angle of departure. Which tutorial is that?
An A.
A, okay.
Yes.
Do you want me to open your answer?
No. Buka je yang lain.
Tepat aja soalan ni. Boleh je, you ada submit tadi, kan?
Ada.
Okay, boleh ke saya buka Nabila punya? Ya, okay. Alright, so which part? The angle of departure. Okay, I will scroll down. Yeah. Okay. Alright. Mana dia? Mrs. Wangsi. Oh, part tu. Alia, one which one? 1A?
1A.
1A, eh? Apple, eh? Okay. Okay, 1A. Alright. Okay, so this is the system. You have 0, yeah, -4 and -6 for the open loop post. And then the question,
Kan dia ada tanya untuk cari angle of departure or arrival tu kan. Dia tak perlu cari tu dia cari.
where appropriate. You see that?
Yes.
Okay, so it depends on your your understanding about the rules. Yeah, that's why it says there where appropriate. Do you, if you think that it need to be calculated, you calculate. If not, you just skip. Clear?
So for Stephen tak payah lah.
Is there any angle of departure there? What do you think?
No.
Why?
Sebab it's all on the real axis.
There are only real open loop poles, right?
Yes.
Okay. There's no conjugate poles. Or or about the arrival, there's no zero. Yeah, open loop zeros. Conjugate open loop zeros. Yeah, complex conjugate open loop zeros, you don't have it. Yeah, the same goes to the post. There's no complex conjugate open loop poles, right? So no need to calculate that. You just play around with the on the real axis and the breakaway.
Okay, thank you, madam.
Clear? All right. Thank you for that question. Any other question? All right, so that's why you understand the 8 rules already. Yeah, but remember, yeah, the 5 basic rules give you um, first information about how the root locus looks like. Okay, do that first. Just briefly sketch your root locus, and then you decide about the additional 3. Okay, right? In fact, rule number 5, yeah, the 5th rule also intended for the root locus that goes towards infinity. Okay, the asymptote calculation, right? Okay, so that one also you can understand, yeah, from the open loop poles and open loop zeros that you have. Yeah, the number of them. Okay, let's continue to the next question. Yeah, tutorial 2A. Yeah. All right, now the question I give you the first part, drawing. Yeah, you have to draw the root locus. Okay, let me open the question first. Okay, that's the question. Okay. All right. If you're not comfortable with the view, yeah, tell me, please. Yeah, I don't know. Yeah, maybe yeah, you cannot see my cursor properly. You don't know which part that I'm talking about. Okay, please let me know. Alright, tutorial 2A. Yeah, draw the root locus, and then secondly you have to design. Okay. Alright, now draw. Okay, let's have a look at your friend's answer. 2A, I think. Yeah. Open back. 4, 5. Okay. And then yes, root locus. Okay, let me check. Yeah, okay. For those who have not yet started answering this one, then you can jot down the answers. Yeah, that I confirm to be correct. The method wise, yes, just take note. Okay. All right. The open loop transfer function. Okay, this is the right way. All right. Um, your friend expand the equation and then get the closed loop transfer function. Quite a long steps there. Okay, plus k. Yeah, plus k there. Okay, all right. Okay. Okay, that's correct. Don't forget the K, okay? Sometimes, yeah, there's possibility, yeah, of you to forget to write the K. Okay, if you don't have the K, you can solve the J omega axis crossing if needed. Yeah, so be careful. All right, 0 minus 4 minus 5 is the open loop poles. Okay, go back. 3 poles only, no zeros, means that asymptote is required. Yeah, okay. And then the basic rule, a basic where's the sketch? No sketch. Part 2 1C, part 2 A. Yeah, okay. So you have the breakaway. Yeah, um Nabila, which one that you think is the answer? Okay, 0 minus 4 minus 5. Okay, if I draw this for you, okay, minus 4 minus 5 and 0, right? Okay, let me take out my, okay. All right, so you have, okay, so you have that, that, and that. Okay, my scale is not correct. Yeah, you use a better scale. Yeah, it's minus 4 there. Minus 4 minus 5, 0. So you know that, okay, from basic rule. Yeah, so this is what I want to look at. Yeah, you try, you need, I want to look at how you draw. Okay. All right, so rule number 3, left. Okay, hold on. Okay, so left, right, and then left again. Okay, so direction, direction. All right, so split. Okay, asymptote, you draw. Okay, it's 60 degree. Okay, it should be 60 degree. Okay, crossing point is there. Okay, okay, right. So, all right, something like that. Okay, crossing is there. Breakaway also need required. Okay, that's why your friend has calculated the breakaway point just now. Okay, so it's clear that it needs to be in between 0 and minus 4. That's why that is the answer. Okay, now the asymptote angle 60, 180, 300 minus 3. So you mark minus 3 there, and yeah, for me it's better to use different color here. Yeah, okay. Okay, minus 3 is there. Yeah, minus 3 is there. Okay, and then you plot your asymptote line. Sebenarnya, actually, you have to draw your asymptote line first, yeah, before you can draw your root locus. Okay, that is not to be crossing over the asymptote line. It should be near. Okay, all right. Okay. Okay, you understand what I mean, yeah? Okay. All right, now crossing, yeah, you calculate. Okay, so next is the what's your answer, Nabila? Is this done yet? What is the value of
Nothing.
k? Mm. You have to determine which row that can become zero, right?
Tak sampai lagi.
Uh, so which one that you think should be the row of zero? The first one, right? Okay, this one. Okay, mana pergi row width-nya? Row width tak ada, eh? Okay, I tak nampak, mungkin in your other page. Okay, let's let's yeah, right. Yeah. Okay, what do you have for the closed loop transfer function characteristic equation? We have oops, what happened? Okay, right, so S3, S2, S1. Okay, so you have 120. Okay, double check, yeah, with your answer if you have 1 and 9 and k. Right. Okay, so let's have a look at your friend's answer just now for the closed loop transfer function. Okay, this is your friend's closed loop transfer function. Okay, I make it a bit bigger. Okay, closed loop transfer function with that equation. That should be kg, yeah, kg, Nabila. Double check with the equation from the lecture slide. Okay, kg over 1 plus kg ish. Okay, all right. Now that's correct. Yeah. Uh, okay. So taking that, yeah, taking the characteristic equation of your closed loop transformation, you fill in the table. Yeah, 129k. I haven't seen anybody who have tried the direct substitution. Yeah, maybe next time. Okay. Now this one, you can continue. For the next cell, yeah, it is negative 1, 9, 20, and k, right? Divide by 9. Okay, all right, and that gives you, what is that? 180 minus k divided by 9, okay, equate it to 0. Why? Because this can be your row of 0. Okay, because you have nothing there. Yeah, on the third column you have nothing, okay, so here is 0. Yeah, okay, so easy answer, 180. Okay, all right. Okay, for the J point, okay, use your PS, the polynomial. Okay, this part. Okay, you write back that equation, and you will get your answer as plus minus J 4.47 something. Okay, calculate that by yourself. Yeah, because why? It can be, yeah, different in terms of decimal point. It depends on your calculation. All right. So that is until there about 2. Yeah, no design yet. Okay. All right. Never mind. Okay. Let's continue next Tuesday. Joey, is it okay? All right, so I can see that you have done your tutorial one. Yeah, you are going towards the design. Yeah, so I will wait for you on Tuesday. Okay, please, yeah, try tutorial two. You have several. I gave you like I think A, B, C, maybe until D. Yeah, that I gave you. Yeah, D, isn't it? Yes, I think until D, to D. Yeah, there you are. Your tutorial A, B, C, and D. Okay. All right. So let's continue on Tuesday. As I've told you, I will probably brief a bit about frequency response. Um, um, I will do that quickly, a bit. Okay, and then we will continue with the design. Okay. So as much as possible, please do this tutorial. I hope that I can see all A until D answers from you. Okay, because yeah, weekend ni ada ya ada masa ya. Okay, please try. Okay, let's continue this our discussion later. All right, guys. I think if there's no more question, is there any question?
No, so far.
Good so far.
Yeah.
Okay, before you do your tutorial, now you finish and I brief you about 4 tutorials already. How much confidence level that has increased in you? What do you think, Mike? Have you get more confident in sketching root locus, solving this the question? What do you think?
um, Better than the first
Better.
time I learned it. Yeah.
In terms of percentage, increase how much?
30,
Berapa?
30.
30 saja. Sikit tau.
Sebab belum habis buat latihan kan. Baru sampai
Belum
C.
ni. Okay. Winston, how confident are you now? Not much. Not much. So means that you have to practice and practice. Okay. Okay. Look again with what we have discussed today. Plus, you have to go fast now. Okay. No time to lose. Okay. Next week, 3 papers. Okay. You need to divide your time. Yeah. Okay. Have a good rest at night, and then wake up early in the morning. Do your exercise. Yeah. Read back the notes. Okay. Ask your friend. You have your friends. Okay, you can see that your friends answered as I did commented just now. Yeah, so some of the things that are correct and or some of the things that need to be corrected. Okay, take note on that. Yeah, you'll be fine. Okay, all right. For the code today is 2433. Please sign in. Okay, so if no question, you can leave the GM. Thank you very much.